go. Um, so today I'm excited to introduce to you Dr. Yeon-Soo Kim. Dr. Kim is a professor at the Northern Arizona University School of Forestry, and she's also affiliated with the Ecological Restoration Institute there. She's an ecological economist with more than a decade of academic and professional experiences in payments for ecosystem services and regional economic impact analysis. She served as a principal investigator on many research projects, including several projects addressing economics of ecological restoration and fuels reduction treatments in the American Southwest. Today, she'll present the results of one of those projects that she worked on through the Ecological Restoration Institute that assembled a team of wildland fire economists to conduct rapid evidence-based assessment for assessing the values of ecological restoration and fuels reduction treatments. Dr. Kim?
Hello.
Yes, we hear you.
Okay, great. So let's get started. I guess we will have a small group here, so hopefully we can have more time to um, have more discussion, question and answers. This is a field of study that I have more questions than the answers for. So let's get started. So I call myself ecological economist, um, which means I'm trying to understand the trade-offs, the discipline of economics within the context of ecology. So this is kind of new field of study that grew out of, large discipline of economics. So today, we'll talk about one of the projects that I did with Ecological Restoration Institute here. And our work, because, where we are, our work is focused on dry conifer forest in the western United States. But from the little bit of information that I have about prairie ecosystem in the Great Plains also suffer from departure from historical condition and the changes in fire condition after European settlements, similar issues. So hopefully you can make that connection. And if there is any specific questions, please let me know at the end of presentation. So the title is Economics of Ecological Restoration and Hazardous Fuel Reduction Treatments. It's come down to a simple question. We're spending this money on fuel treatments. What are we getting? So that's the question that we were often asked. What are the economic returns on investment? The investment on ecological restoration, hazardous fuel reduction, it is federal spending, public money that goes into these management actions. But a lot of times the outcome is ambiguous. That's what we've been hearing. And then, what did we get with all the money we spent on fuel treatments? And how can we do better? And what is our future outlook? So we started with those three questions: past, present, future. And then so we were trying to answer persistent and burning question. I just have a hard time avoiding that cliche, burning questions. Um, so are there questions that you would like to pause on this topic? So I want all of you to think about it a little bit. Alrighty, so let's just give a few introductions to this problem. So I have I had an opportunity to go DC with some people in Ecological Restoration Institute. Um, and in DC, the question is very simple. We have a trade-off. Public money must be justified, and it's kind of economics argument trade-off. So that's economics 101. Every decision involves trade-offs. But if you apply this logic to ecology, I'm sure many of you can relate to this. Everything is connected to everything else, and it gets very complicated. And so I guess it's partially our fault, the economist's fault, that we set up this kind of unrealistic expectation that if we do more fuel management, suppression costs will go down. There was this kind of simple trade-off expectation was set up somehow. And so people who manage the federal budget see fuel treatment budget going up with the suppression cost going up. And they were saying, hey, this look like we're ineffective. And so we were trying to clarify that question. So if you know, all of you fire manager probably are familiar with this fire triangle. So fuel treatments primarily address fuel conditions, but fuel conditions itself doesn't make the fire, right? So we need the oxygen and heat. So if we expand this fire triangle more understanding of what wildfire is, we can factor in the other factors that's driving suppression decision and suppression cost. So, well, you know, there are different scientists kind of look at this problem from one angle and say it's all climate and weather. Fire is inherently random event. We cannot prevent it. Extreme fire conditions gonna drive wildfire. So, you know, there are people who's looking at that in that angle. And then some people look at it in more socioeconomic factors that affecting ignition itself. So we have a lot more human-caused ignitions. So people look at it that way. And then the values at risk is continuously increasing because people are building more and more into the wildland urban interface. So when values at risk is increasing, of course, we have to spend more money on suppression itself. But also, we need to spend more money to try to protect these areas too. So one of the kind of clarification that economists can offer is that suppression and fuel management are not substitutes. We have to, these are complements. That's economic jargon, I guess. So these both things, we use these both management tools to protect values. So to see these as a substitute are maybe the mistake. And that was that goes way back in 1920s that when first this wildland fire economists set up their economic model. They just set this as like a suppression as an output of fuel management. So anyway, so there was a whole articles that criticized that part. Anyway, so just the take-home message is that the fire is complex, like you all know, and the fuel management and suppression, we cannot see this as a strict trade-off or substitute problem. So what are the why the other questions? So I just explained some of it, but why are the question about what we get out of fuel treatment? Why that question so difficult to answer, and why do they persist? And the first bullet point I already explained, economic relationship between investment and treatment and a reduction in suppression cost is complicated. These are not necessarily one-to-one trade-off. And the second one is scale. Well, so I get this impression that people in DC like to have simple answers. So in a whole nation, if we spend this much money on fuel management, we will save this much money on suppression costs. And that's just, the whole West and Great Plains are totally different ecosystems. So our fuel conditions are different, forest types are different, fire regimes are different. So in maybe some part of the U.S., the frequent fire is more natural, but some part of the U.S. more long-term severe fire. I mean, the long interval severe fire or maybe natural fire regime. So to generalize cost or effectiveness of fuel treatment in this large scale is very difficult. And suppression decisions are decisions. So we choose to suppress fire. So it's not entirely driven by fire itself. So even low intensity fire may need to be suppressed if it's very close to somebody's house. So, and there were actually interesting social science research that link the newspaper coverage with the suppression cost. So even the same size of fire, if it gets more newspaper coverage, the suppression cost was higher. So I mean, there were a lot of internal motivations and social factors that driving suppression decisions. So it's hard to quantify all that. And fires will happen, it's inevitable. And even with the best management, extreme weather condition will drive fire. And another external cost. So like homeowners' point of view, they're not really discouraged building into urban wildland interface because they're not the one who will pay for fire suppression if fire happens. So that's, this is a classic problem of externality. And this is why people are building in the edges of sand dune and when, looking out the ocean, or people building in floodplains and all this stuff. So some part of the cost is externalized and not fully realized by the decision makers. And then the time factor, and I think a prairie ecosystem is more sensitive to this. But even in the West, in Ponderosa Pine, our fuel treatment have a lifespan, and it may be effective for 10, 15 years, but we will have to treat it over and over. So the the treatments that has the time duration, so it's not entirely effective reducing fire risk over a long time. So all these factors make our question difficult to answer. So what can we say? What the economists say about this problem? So that's the presentation today. And this is today's presentation with that background. In today's presentation, I will talk about a little bit about ERI, what we do, and evidence-based conservation method that we use to answer the question. And I will summarize the persistence question for wildfire economics. We had to reframe the questions a little bit and make it more answerable by us. So hopefully you can see its relevance to your management too. And then I will talk a little bit. So there are two ways we try to answer the question. So the questions about the past, was fuel treatment effective? In what sense? We use the rapid evidence-based assessment to evaluate the legacy. And then I will introduce some innovations that made for answering the persistent questions. So this whole workshop started when Office of Wildland Fire contracted Ecological Restoration Institute, and they just wanted to know, what they can say about effectiveness of fuel treatments. And one of the limitation we had was that DOI, Department of Interior, who commissioned this work, they really wanted the third party assessment. So they wanted, I guess, mostly academics. They didn't want the agency, mostly agency scientists, justifying agency actions. I guess that was the logic. But the problem we had was, a lot of expertise on actually wildland fire and wildland fire economics is in with the Forest Service Research Station. So we invited some of those experts, but we were we invited mostly economists that working in the university. So a little bit about Ecological Restoration Institute. We are pioneer in conducting research and um, disseminating information about restoration treatment outcomes, strategy, and techniques in the Southwest. So this work is, like I said before, focused on more dry conifer forest in the West. And these are the people who participated, our leadership in Ecological Restoration Institute, and Diane Bozic, who unfortunately couldn't join us today, but she's really the one who provide the leadership and a lot of writing in our report. And our final report is on ERI website if you are interested. And also there is a fact sheet summary of our study as well. And other participants is myself, my grad student, and Krista Giebert. She's worked in this field a long time, and she came to the workshop and provides Forest Service point of view. And Doug Rideout in Colorado State, and Kim Rollins and Mike Tyler and John Yoder, and from different universities. Okay, so a little more background on ERI. There's a ERI website. It's www.eri.nau.edu. And if you go there, you will see a lot of works that's been done by ERI. And one of the methodology we've been using is evidence-based conservation project. So what is evidence-based? It's um, well, so I will talk about that methodology a little bit later on. So I just want to mention that there are other projects that use the similar methodologies to see the effectiveness of fuel treatments and ecological restoration. Persistent questions. So how we summarize the persistent question. So it's the extension of past, present, future question. Have the past 10 years of hazardous fuel reduction treatment made a difference? What is the relative value of treatment programs at the landscape scale? And how can we improve current and future economic returns? And what is future suppression cost look like? And when or will investment in fuel reduction treatment lead to a reduction in suppression cost? And for the last question, I will just tell you right now, suppression cost itself, reduction in suppression cost itself is not going to be enough justification for fuel reduction treatment for the reasons I just talked about. So this question needs, the last question really needs to be reframed. If we keep choose to suppress every fire there is, suppression cost is not going to go down. So that's the question for the last one. Okay, so for the first question, we did the evidence-based assessment, and the last four questions, we tried the different methods to to offer some more broad-scale answers. We have um, many kind of non-market studies that accounted the different costs and benefits of treatment but those were applied in small scale for individual fires. So our focus was trying to bring a little more broader perspective into this. Okay, so what is evidence-based assessment? And this is called systematic review. And systematic review is developed. It's well developed the methodology of literature. It's basically literature review, but doing it systematically. So systematic review started as a clearly formulated question and systematic explicit method to find the studies. So if anybody wants to duplicate what we did, they can follow our methodology and go to the same conclusion. This methodology is developed in medical field, and basically in medical field, there are a lot of experiments and different drugs and, in different populations. So they wanted they want to develop a way to summarize the finding of the field. So say ibuprofen. If you give ibuprofen to uh, population A, do they have a reduced headache? That's the outcome. So intervention, outcome, subjects are clearly defined, and then they do literature reviews and find all the known papers on that topic and do that in systematic way to draw conclusions. So that's the and this methodology developed in medical field, and now we're applying it to conservation field. And specifically, ERI has done bunch of studies on this, trying to draw a broad conclusion, like what do we know so far about this particular question. So breaking down the complexity. So our intervention, if you look at the bottom of the screen, intervention is fuel treatment. So in this case, we define it as thin burn or thin burn treatment. I understand in prairie ecosystem in Great Plains, it's mostly prescribed burning, but in our forest system, prescribed burning in current condition is very dangerous. So we have to thin out some before we can get to the prescribed burning. So our intervention, ibuprofen or some other drug in the medical term, is the treatment. So thin burn or thin burn combination treatment. And so are these treatments produce desired outcome? So we search all the literatures who about the studies that looked at the treatment effect on reduced fire hazard, protection of WUI, reduced suppression cost, and the ecosystem health, ecosystem services. We try to find everything that describe the outcome of treatments. So this is the specifics on systematic review question. So intervention I to population P produce outcome O. So in this case, subject, our population is western dry forest burned in a wildfire, and we focus on actual effect of fire, not modeled studies. And intervention was fuel treatment, including thinner burn. And we looked at the studies that compared the treated acre with untreated acre. And outcome is everything you can imagine. We were trying to find um, all the studies that describe some kind of outcomes of fuel treatments after fire. So, and we found 33 studies on describe the fuel treatment effectiveness. And we try to classify this into ecosystem services criteria. And since Millennium Assessment, this is a UN commissioned big study on ecosystem states of the world, and they classified the link from ecosystem to human well-being into these four categories. And there are a lot of different classification, but these four categories, this classification system kind of sticked, and a lot of people use this classification now. So supporting services, provisioning services, regulating services, and cultural services. So we found these 33 studies that met our search criteria, and we classify these studies into these four groups. So first, treatment effectiveness in ecosystem services. It's regulated. So what's the impact on regulating services? So treatments improve regulating services, which means benefits that we obtain from regulating of ecosystems processes. So fire risk and severity reduction. And out of 33 studies, there were, I can't remember now, 46 relationship 40 something relationships that we summarize. So these actually the numbers of relationship described here is more than 33. And so 24 cases described fire risk reduction, fire risk and severity reduction, and four cases documented that treatments improve firefighting effectiveness. And treatments in dry conifer forest also improve carbon sequestration because you know carbon is lost when you thin or burn, but it reduces the chance of catastrophic carbon release in case of wildfire. So in at least in this ecosystem, actually carbon outcome is positive with treatment. And so these are other studies that didn't meet our search criteria per se, because these two of these are actually other meta studies. So first meta studies is done by ERI, and they included um, a lot of different studies that include actual and modeling studies. So their cases were a lot bigger. So review of 39 studies and metadata from 54 studies, and their conclusion is thinning and burning treatments do have effect consistent with the restoration of low severity wildfire. And other meta-studies, Omi and Martinson's paper, this was a joint fire science program funded study, and they found the overall mean effect of fuel treatment, reduction of canopy volume scorch, and reduction of scorching height. And there are a bunch of other fire modeling studies that shows that measurements, they show the carbon balance of Ponderosa pine ecosystem is after 15 years that this is a study that looked at the effects of severe wildfire over long term. So even after 15 years, forest is still emitting carbon instead of taking in. So the consequences of catastrophic fire is quite severe long term. So that is about regulating service, but a lot of people still make an argument that regulating services are not enough justification because these things realize only fire happens. So I am aware of some papers that talks about like the chances of actual wildfire hitting the treated acre during the treatment uh, longevity period is quite small. That's not what I think, and methodology of the paper is quite flawed, I was told. But as a fire managers, you guys probably have feeling that if this is a regulating service is good enough justification for treatments or not. So, and other services can is realized without the catastrophic fire itself. It's just restoring ecosystem itself has a value. It's supporting services. It's supporting services are the services that are necessary for the production of all other ecosystem services, and it can be indirect and occur in a long time, but we noticed a larger data gap on this one. And so treatments in dry conifer forests is if have a positive effect in soil formation, nitrogen recycling, understory productivity, and promoting biodiversity and protecting wildlife habitat. But we did find one study, this red one is the number of cases on negative effect. Treatments negatively affected soil formation and nitrogen cycling was a one case each. And the three cases documented the kind of neutral effect on understory, promoting understory productivity. Okay, and the last one on supporting services. Although this study is not selected, it didn't meet our search criteria, but you might be interested in knowing this paper in Journal of Forestry in 2004. They summarize people's willingness to pay for protecting wildlife habitat. In this case, um, critical habitat for Mexican spotted owl and other endangered species. Any willingness to pay studies in 3 different states, they came up with this kind of meta equation that willingness to pay for household is the, um, positive, and it depends on the acre reduction anyway. So there's that. And then there were another meta study, the systematic review study that done by ERI. Liz Kalis, she's a systematic review expert, and she did the effect, fuel, and restoration treatments on small mammal and bird species, and she found positive or neutral effects. And surprisingly, we couldn't really find any studies that met our search criteria in terms of provisioning services or cultural services. So provisioning services, cultural services is a product or services that we get out of ecosystem, but treatment. So this is kind of another research area we want to look into. We want to look at more large scale study that looked at this treatment effectiveness on protecting properties and other recreation opportunities and other cultural services. But there are a whole bunch of kind of um, case studies that looked at treatment effectiveness on protecting timber resources and property values. And Bartlett's studies in 2001 compared the wildfire to class 2 hurricane. So he compared the potential timber loss due to wildfire in Florida. And other studies, Western Forest Leadership Coalition, they documented the cost of big fires in the West. Um, and then there are studies that looked at the treatment or wildfire effects on real estate value. So treatments improve um, property values, and wildfire in the vicinity reduce home values. So those are the studies that looked at um, the effect on real estate value, but those didn't meet our search criteria. And so what other things we can say about this? Economic studies that comprehensively evaluate the economic efficiency of fuel program, and multiple scale are still lacking. Why? Because the reasons we talked about in the introduction, because fire is complicated and there is a problem with scale, time, and endogeneity is it's an economics term, but in simple ways, it's like this. Fuel treatments, so only way to really experiment with the fuel treatment is that, do the treatment in one area and don't do the treatment in the other area and burn both areas and compare the result. That's the only certain way to really know. But that's, of course, not possible. And treatments go into places that's more fire prone. I mean, as managers, you will know you wouldn't put the treatment in the area that's unlikely, the fire is unlikely. So treatments go into the area with more higher risk, means maybe treated area there is more fires. So that creates this problem. So treatment may look ineffective if more fire happens there. Hopefully you can see what I mean. Like, the flu vaccines are given to more elderly population. So the fact that more elderly population die of flu doesn't mean the um, flu vaccine was ineffective. It means those populations are more vulnerable to flu, so maybe we need more vaccine. So we need to understand this complexity carefully. And of course, a lot of ecosystem services like biodiversity or soil formation, stuff like that doesn't have a clear economic value. So it's hard to justify protection of those resources in dollar terms. So what can we do about this? So the last four questions, what can we do better now and what it's going to look like in the future? So we made the progress, economists and fire ecologists and other people made the progress, and recent innovation, Flame Act 2009, trying to develop a cohesive strategy and trying to evaluate fire risk in multiple scale and trying to focus more um, risk area with more targeted fuel treatments. That's one area we're making progress. Another one is collaborative forest landscape restoration program. I don't know if this is going on in the Great Plains, but in the West there are several collaboratives or moving ahead with the collaboratively developed landscape level restoration programs. One of um, those projects going on here in Arizona is Full Forest Restoration Project. So we will soon have the largest scale NEPA and largest scale restoration thinning will go on here pretty soon. And one of the requirements for those targeted funding for collaborative forest landscape restoration program is RCAT, is risk and cost analysis tool. And this is developed by the team of Forest Service scientists, and Krista Giebert, who came to our workshop, is one of the leader on this. And so this involves fire modeling. So RCAT, what they can do is to do the fire assessment before and after the treatment and simulate that with the fire modeling tool, and then use regression model. This is developed from observation of suppression costs in federal land in for over a number of years, and then they have a stratified cost index, so they can actually calculate for you how much fuel suppression costs reduction you can expect from the treatments. But I mean, of course, this is just on average based on simulation. And another way of looking at this is looking at the treatments not in treatment without treatment, it's never that extreme. A lot of times managers need to compare relative effectiveness of different treatment scenario over landscape. So Doug Rideout, Colorado State, he developed this program, Starfire. If you go to this website, there is a website address. You can read about his logic. And so, the thing is, we will never gonna get to the bottom of total economic value of ecosystem services, biodiversity, ecosystem values in economic dollar term is very difficult. But his contention is that managers, if you have a group of managers and have a discussion, they know which areas are more higher value than the other one. So he developed this kind of rating system of comparing different management scenario. It's called marginal attribute rating system. So based on this relative values of alternative fire management scenarios, we can evaluate the effectiveness of different management scenarios. So that's his model, and a case study application from Colorado. The treatments, high level, more intense field treatments, improve landscape conditions 20%. So again, his logic is we can evaluate intensive treatment versus medium or low intensity treatments and evaluate the relative values. So that's another way of looking at the effectiveness of field treatment. And how can we improve current and future economic return? So this is Kim Rollins and Mike Tyler. They are the economists who worked in Great Basin sagebrush ecosystem. So they developed this economic model and apply efficiency of fuel treatment in different ecosystem setting. And so they simplified and developed a stylized state transition model. So their theoretical ecological basis of their economic model is that the state transition models. So if you just let the ecosystem degrade or burn in high intensity fire, it will transition into another ecosystem state. So in Ponderosa pine ecosystem, there were a lot of studies done and say if this ecosystem burn in high intensity, it's not going to come back as a forest on its own. It's going to move into grassland. And so they looked at this probability of system transition and calculated the economic efficiency of applying fuel treatment in different ecosystem states. So that's quite complex. Their economic model is very complex. But the point here, what the conclusion is that management actions, if we wait too long and let the ecosystem degrade too much, it's not going to be very effective, and it's not going to save us a lot of money in the long term. So the take-home message from their study is that we need to apply fuel treatment when ecosystem is relatively in good state. Then we can get more bang for the buck, so to speak. So that's their conclusion. And so I won't go into that. And another study we did out of this wildland fire economics workshop is that what does the future look like, and in terms of wildland urban interface and climate change effects. And this study is actually, to be honest, was very limited because John Yoder he's very great economist and he has a great econometrics model, but we are limited by the um, kind of data that's available to us. So the location of fuel treatments and cost, and location of suppression um, fires and their suppression cost and the burn intensity, all those are in different databases and it's hard to link. So at the end, what he did is uh, aggregate these data at county level. So look at all the western counties, and in the county, how much treatment went in, and then what kind of fires happened and how much it cost. And he run the model that way. And that's the best he could do with the limited data we have. So the result, we couldn't really show the effectiveness of fuel treatments with the data we have. But what was really interesting is that maybe this is kind of common sense, but larger areas of urban wildland interface and intermix, it complicates wildfire suppression sufficiently and it leads to more costly suppression. So urban wildland intermix actually drives wildfire suppression cost more. And so how the urban wildland interfaces is spatially distributed also affect suppression cost. And so I guess we couldn't really find the climate change effects. It's happened to be wet year for a while. So anyway, so we couldn't really find the definite effect on the climate change effect on fuel suppression cost. But like we all know, the WUI expansion will drive up the suppression cost in the future. That much we can say. So to sum it up, assessing the value of restoration and hazardous fuel treatment only on the base of reducing suppression costs, it may be a mistake. And we need to understand the full complexity and the full economic and ecological values of treatments. And our evidence-based systematic review show that treatment improve value of ecosystem services. And the question that when or will investment in fuel reduction treatment lead to reduction in suppression cost, it cannot be answered in a conventional trade-off analysis. But we need new perspective that appreciating this complexity, and we showed a few example how this can be done. And one is the Doug Rideout's model, that relative effectiveness of different treatment scenario. That's one way we can explore. The other way is that maybe the treatments, I mean, a lot of fire ecologists argued this before. Treatments is not about limiting fire size per se, but it's for making the fire more acceptable in the landscape. And then maybe we should look at more on the link between fire behavior characteristics and the suppression costs and the treatment. And another conclusion, treatments may be more effective in the area that's relatively healthier, which is kind of could be surprising conclusion. Okay, it's the conclusion of my presentation, and if you have any question, I would love to answer. Thank you.
Thank you, Dr. Kim. And if you do have questions, feel free to type them in the chat box. And while people are thinking a little bit about what you presented, the one question I have is, can you tell us a little bit about the feedback from this study? The folks that were interested in contracting the research, and have you heard any feedback from people in Washington who are considering budgets and things like that?
Yeah. Generally the feedback was positive from the agencies, and I presented this in the webinar for Southwest Fire Consortium and also Society of American Foresters meeting, and ecologists actually appreciates that for us economists to say, this is really complex and we need to understand, the ecological underlining of this problem. And so they, we got a positive feedback on that, this is not simple benefit cost analysis kind of problem. But, some people in OMB, it seems like, their job is to say no, I guess. I don't know, but they keep saying, this is only anecdotal evidence, and I don't know how large scale can we be. We were, specifically trying to move away from the anecdotal studies and say, this is all the studies that's been done. I mean, what can we say about this? So we were trying to draw that kind of conclusion, but it seems like a national budget is driven by something else, so I don't know what to say about that. But hopefully we made some, uh, you know, for managers to justify their actions.
We do have one question that's been typed into the chat box. It says it's
Yeah.
all about risk reduction now, how not suppression costs. How can the effectiveness of federal hazardous fuel reduction programs be measured in terms of risk reduction? Do you have any thoughts on that?
Yeah, that's a good question. How would you, I mean, this is what I learned from the fire ecologists. How you define risk? It's like, is it fire severity or the, ignition itself? And so there were studies that try to look at, um, there hasn't been much studies. Actually, this is one of the things that I'm trying to look at and that, how treatment affects on fire intensity itself. And then maybe it reduce the risk, that way, the reduce severity, reduce risk.
Risk is
Intensity.
likelihood, intensity, and susceptibility.
Yeah, so I mean, fuel reduction doesn't really do much about the ignition itself, but there is a fire model. I mean, this would be probably the question for fire ecologists that, um, treatment is effective on, reducing. Well, one of the things I actually, interesting to me, I have a question. You know, in Southwest at least, our ecological restoration goal is reintroduction of low severity fire and frequent fire. And so is that like risk reduction? So if treatment reduce enough, fire intensity, but maybe it's, is maybe it spread faster, is that acceptable? I mean, what is acceptable to the public is probably different than what's acceptable for fire ecologists. So, I mean, that's my, um, long way answer for your
It's
question that I don't really know,
it's a
how
very
we need to,
difficult question.
yeah, we need to define. I mean, we need a public forum to decide, like, the public need to decide, restore natural forest is what they want, and then they have to accept some smoke and fire.
Hmm. Uh, Philip said, "How do you think the shifting of ecosystem states will affect the cost of suppression fuels reduction?" So I think that's talking about. You mentioned if you do your treatment while the ecosystem is fairly good condition, you get a better result than if you wait until it's degraded.
Yeah, and The cost of suppression. So you get a better result on restoring ecosystem to. So the success probability of treatment is higher if the ecosystem is relatively in good condition. And it's so after the transition, well, in Ponderosa system, we look at the, like forest system, and then the after transition, it would be grassland. So here's the problem. I just keep bringing problem instead of answers. Like I said, in this ecosystem, our ecological restoration goal is to bringing low intensity fire. So, and in that case, if we suppress all the fires the way we suppress now, fire suppression cost would be actually higher in the restored ecosystem. I don't know if that makes sense to people, but you know what I mean? So that's the difficulty. So shifting ecosystem state, how that affects the cost of suppression. Well, so keeping ecosystem in the healthy state would help us, fuel reduction treatment would be easier, and in that way, we may not even have to treat in this environment if public say, low intensity fire is acceptable, and then we can use the natural fire and just watch, natural fire burn, and it would be minimal suppression cost. But if we choose to suppress the way we do and not use natural fire as a management tool, suppression costs may be higher. So,
Hmm. So the work that you've done on this question has been focused on the southwestern systems. Have you talked at all about trying to see if there would be any differences in the outcomes in more eastern or other types of ecosystems?
yeah, I mean, if someone from Great Plains, I mean, the methodology, the systematic review methodology is very clear. So, it would be good master's project to do this and say, in prairie ecosystem, this is, treatment effectiveness that's revealed from the scientific studies for last many years.
Hmm.
So it would be a good research topic for somebody.
Yeah. Does anyone else have any questions? It doesn't look like anyone's typing, so I think we've exhausted you for today. Um,
Okay.
Thank you, Dr. Kim. I appreciate you visiting with us and sharing your research today. And we will get this recorded and placed on the internet for people to share. And again, if any of you were interested in continuing education credits, please send me an email and we'll get that taken care of in the next couple of days. Thank you,
Thank you
Dr.
very
Kim.
much for